Materials supplied by Microsoft Corporation may be used for internal review, analysis, or research only. Any editing, reproduction, publication, rebroadcast, public showing, internet, or public display is forbidden and may violate copyright law.
Hey guys, I'm happy to introduce William Adams, who's from our own team, for today's Tech Talk. And William is like a connoisseur of non-Microsoft languages. He's been known to develop in Lua and Node and all other kinds of kind of fancy things that I don't even know about. So today, William and his team have also built this proxy gateway, which is based in Node. And William's going to talk a little bit about his learnings in Node and how to kind of quickly get web services up using that. Please give William a hand.
Thank you, Girish. How many of you know anything about Node? Okay, how many of you are doing mass scale web servers of any kind? All right, it's quasi good audience. So, I'm going to speak slowly because there's not much material. No. First of all, if you've ever heard anything about Node, there's some magic around it. A lot of people don't understand what it is. So I'm going to go through what is Node exactly, and then I'm going to talk about why is it good, some pitfalls of it, and I'm going to show specifically how we use it. I'm going to show some code. I'm going to show some charts, stuff like that. Along the way, ask questions. We don't have to save it for the end. So if you see anything that piques your interest, raise your hand. And if I'm not trying to ignore you, I'll try to answer your question. All right. So using Node, web services magic. Okay, so what is Node? First of all, there's some guys that a few years ago went off and created this thing called Node.js. They've got a website, nodejs.org. You can go there and read the history and all that sort of stuff. But what is it? Node is an executable. Node.exe, there's actually a file. You know, it's a program. That's all it is. It's just a program. It so happens to embed stuff, and I'll go through that list in the next slide. Also, it's an application environment. So just like IIS, you can put plugins and add-ons and all that other sort of stuff. Node is the same kind of thing. It's an executable, and there's a mechanism whereby you can grab modules that all sorts of people in the world are developing and kind of shove them into your environment. That gives you access to those modules when you're developing your applications, okay? This is the same thing you see with Apache, IIS, Node. Any of these web application environments do the same sort of thing. In the Node environment, it's called NPM, Node Package Manager. So there's websites out there that contain packages that you can easily just say npm install Azure, and you get a whole bunch of stuff that's related to Azure installed into your environment, and you can then use it. That's actually a big deal because it makes it really brain-dead simple to add functionality to your environment without having to go and compile a whole bunch of weird stuff, okay? What is it good for? It's good for networking apps. It's good because it works across multiple platforms, and by that I mean not just different flavors of Windows, but truly different platforms, everything from a Raspberry Pi to a home router to a Linux server to, of course, Azure servers, okay? And it's good for the environment. Why? Because, as I'll show later, it uses typically less resources to handle multiple transactions with Node than some other approaches. And I'll dive into what that really means in the next slide. Yeah. You're actually supposed to use this mic. Here, I'll give the mic to the audience so you guys can ask.
The question I asked was, surely a module that's widely used on Linux would likely be assuming that it's running on Linux and make calls into an operating system that isn't Windows, and likewise something that works extremely well on Windows probably makes assumptions that it's on Windows?
Depends on the exact module. If the module is relying on things that are within the node environment, that's the core environment, then no. That core environment's everywhere, so it's safe, right? Now, all the things like file access, even starting threads, simple things like that, that's in Node, so that's going to work everywhere. If you want to rely on something like WinCNG, the new crypto libraries, that's only on Windows. You're stuck, right? It's only going to be a module that's going to run on Windows. Now, Node so happens to have crypto built in, so maybe that's not a good example. If you're going to do a UI library that uses user32, because you're doing that for some reason, then yeah, you're stuck with Windows. Most of the packages that are popular work across multiple environments, probably with a leaning towards Linux, right? But there's a lot of modules that just work everywhere because they only rely on the core Node stuff plus JavaScript, and that's about it, right?
Like there are a lot of Node developers who use Macs too, so people are supporting that.
Yeah, so anyone who wants to be popular will make sure that their module works in a lot of different places. But you're absolutely right. If you do something, and I actually have an example of that we did. If you have something that's very platform specific, you're stuck to that platform, right? All right. So what's in the box? What's in that node.exe? Well, there's a whole bunch of stuff. There's OpenSSL, which is the library that pretty much everyone in the world uses when they're doing crypto, at least when you're doing it in the Linux environment, even in Windows. There's V8, which is the JavaScript VM that was originally developed by Google, and now it's kind of open source. There's zlib for compression. There's HTTP parse, which does all the lowest level HTTP parsing if you're doing that in Node. And then there's this core thing called libuv, which is where the eventing, threading, scheduling, low-level socket, low-level file access stuff all lives in libuv. That's kind of, really libuv is the core of what I would say is Node. The fact that it uses the V8 JavaScript VM, that's glue on top. Really the core of it, without libuv, you would not have Node because that's where all the asynchronous processing occurs. And that's really the essence of what is Node, okay? So there's libuv. You actually don't need Node at all to use libuv. It's just a library that Microsoft has actually contributed to as well. You could just go and use raw libuv, and there are now a lot of projects that do that because it gives them the core async communications mechanism that they want, okay? So these are the things that go into the exe. And you notice that I listed the V8's actually C and C++. These are all written in C and C++. The reason that is, and the reason they end up here is because they're written in C. They are so portable, and in many cases they've been around for so many years that it's really easy to find them in every platform. Like if you've ever played with zlib, that's a compression library that's existed for, I don't know, maybe 10 or 15 years, maybe 20, a long time. It's probably ported to everything from your watch to your cell phone to your supercomputer. So it's everywhere. HTTP parse, it's like one file. Straight C, not a lot of fancy stuff, works everywhere. The V8 engine is kind of a pig. It's really hard to compile in a lot of places, but since people are so motivated to do it, it ends up working everywhere, or at least most of the places that you're interested in doing this kind of application. OpenSSL has been around for thousands of years. Everyone uses it, so it compiles everywhere. That's pretty much the core of what is Node. What also comes with is the npm install package, which we briefly talked about. That means that if you go to the nodejs.org website and install Node, you can get the npm package installer and just start saying npm install this, that, just to play with stuff, right? So a lot comes in the box. You can get up and running really easily, blah, blah, blah. What does it look like? So this is an example of a very typical Hello World server written in Node. This is JavaScript code. Okay. If you don't know what JavaScript looks like, it looks like C or C#. It probably looks closer to C#, actually, because it uses var and curly braces. Other than that, these are all standard C kind of looking languages, right? Curly braces, variables, blah, 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 okay? And the only thing that's going on here is at the top it says var HTTP require blah, blah, blah. It's going to use the HTTP module, okay? The second line is create the server, http.create server. That's just calling a function. Anonymous functions, that's a JavaScript thing. Lots of languages have that. You could pull that function out and make it a separate function if you don't like doing the anonymous function sort of thing. Doesn't really matter, okay? What happens here is when you say create server, you hand it a function who has a signature that says request and response. Your function is going to be called, you're going to be handed a request object which has the headers. This is HTTP. So the headers, which contains also the resource, the verb that they're looking for, whatever. And you're also handed a response object where you're going to write back your response, right? Great. In this particular case, I'm doing write head 200, okay. Here's a header, content type, text plain, the body, hello world, and I'm going to listen on port 1337, and then I log to the console. This is how I run it, node.exe, server.js. Now my server's up and running, listening on port 1337. If anyone connects to it, I'm just going to hand back hello world. That's the content, okay? So 2, 3, 4, 5, 6 lines of code. You've got an HTTP server that's very simple, right? You don't have to deal with that. Your function is called appropriately. When you say create server, that's creating the event loop. The magic's happening there, right? You don't deal with the garbage collection. You don't deal with opening, closing sockets, accepting, nothing. You just say, he's going to hand me a request. I'm going to spew into the response. Done. Beyond that, you don't know how it happens. In fact, this same server can handle 10,000 concurrent connections without you changing a lick of code, right? Or one connection. You don't know, you don't care, it just will, right? That's the whole magic here, if there's any magic, right? Yeah. It depends. You can get a you can use Eclipse if you wanted to, and there's plugins for that to support Node specifically. So any environment which would support JavaScript, Visual Studio, we have a lot more support now than we did before, because it's not just JavaScript for the browser. People are using it for other stuff. You can just use a plain old text editor if you're bent that way. I am. So I just use text, and most of my debugging is print, printf. Otherwise, you can get a very Node-specific IDE that's specifically for Node, and a couple of those are laying around. But Eclipse, Visual Studio, and a good editor like Sublime Text or something like that, that's what most people do, right? Any more questions so far? Alrighty. So there you go. That's your basic server in Node, and very specifically an HTTP server, okay? All right, so what did we, what's going on here? What are the key benefits or aspects of Node? One of the primary things to realize is that it's single-threaded, which is kind of a funny thing to think about when you consider, what do you mean 10,000 concurrent transactions with a single thread? How does that work, right? This is kind of core to the architecture. It's IO event driven. This is a key aspect, which is a switch from, if you've used Apache in the past, for example, or even IIS, for the longest time, we used to think having a bigger machine was the way to get higher throughput and connections, right? It's like, well, new connections spin up more threads. This is the way the Linux world used to work. This is the way we kind of used to work. Later on, we came and said, oh, I/O completion ports and things change. But basically, it's a shift from per thread, one thread per connection, to saying, well, wait a minute. Most of the time, those threads are just waiting. And the context switching you're doing in the kernel to go between those threads is killing you. They're blocking threads. You have to context switch, and that kills your perf. So Node comes along. Now, Node isn't the only thing that does this, but Node comes along and says, I'm going to be event-driven. Since I'm waiting most of the time anyway, there's no point in me having multiple threads. I have one thread, and all the things that would block, I'll put on a queue, and then as they get unblocked, I will service them, right? So the whole core of what libuv is doing for you is running an event loop, a scheduler, that's basically saying, oh, you were about to read from this socket. You would block, so I'm going to put you on this list over here. And then if you're in the Linux world, it'll do a select. It does an epoll. It's not a select. And it'll say, tell me when that thing has something. Tell me when it's ready to be read from. Okay? Meanwhile, I'm going to take the next task, and I'm going to go execute that until it blocks. Right? And when it blocks, it'll put it on the list and say, tell me when something happens to that. So it's just kind of this round-robin loop that's going, is it blocking? OK, put it on the list. Oh, it's not blocking, service it. You know, that's what's happening in the event loop. Right? That way, if you're not, as long as you're not CPU bound, you're just going to churn through that thing really fast. Yeah. Microphone.
Can you hear me now? Oh, okay, great. So isn't that just moving the task switching from Windows core, like Windows task scheduler, to that Node task scheduler? Yes. Is that the same thing? So then where is performance gain then?
So let's think about how the Windows kernel works, okay? Preemptive multi blah, 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 right? Preemptive multitasking is a killer because it just interrupts you whenever it feels like it. You don't have any control over that, right? So you're going to, if you did it per thread and you're blocked, you know, you're waiting for I/O, whether you're doing anything or not, it's not until the next time quanta, or maybe the scheduler is really smart and it says, well, you're blocked, so I'll switch to the next guy. Well, context switching of threads is kind of expensive because you have to take the stack, you know, of that thread and go, oh, now that one, now execute, oh, it's blocked, okay, save the stack, okay, next one, you know. Stacks for threads are pretty darn heavy, right? I mean, it's not a small thing. So context switching of a thread in the OS is an expensive operation. In Node, a thread or a task is nothing more than a little tiny bit of memory. It's just an object. It's just a pointer. So I'm just going to go, done, that one. That's my context switch, is switching a pointer. Done. There's no stack, because I'm only a single thread, so I never swap out my stack, right, the thread stack. So that's why context switching in Node is that, because you're not really context switching in a preemptive multi-threading sort of way, right? So now you get the question of, well, is your scheduler in Node smarter than my scheduler in the OS? Well, yes, for this task it is, because the only thing that will switch you is you're done with the task or you're blocked on I/O. And I know exactly when you're blocked on I/O. Nothing else is going to get you active again other than the fact that you have I/O operations ready, right? So it's very targeted. It's a very targeted scheduler. Yes. Aha. We'll get to that. So I'm going to ignore you for now, and we'll come back to that. If I don't answer it, then we'll come back, and you can ask it again. All right, and I actually talked about it even on this slide. So I/O event-driven, that's a key thing. Just remember that this node thing is designed for things that are I/O bound, right? It's network, web application servers. You're probably not going to use Node as the core eventing loop of a game. It's not good at that because it's waiting for I/O. Games are driven by a clock. You could use it for that, but your frame rate's going to get kind of weird because you're going to also share with the I/O that's supposed to be going on that's not actually going on. And games don't have 10,000 concurrent connections unless it's the game server and it's a multi-user environment. All right. Async I/O by default. All of the socket and file stuff, if you use the Node core libraries, are all async by default. So you can screw that up. But by default, everything is async. So you don't really have to worry about it. When you say socket receive, then that's going to be async. You don't, just like the magic we saw in the first thing, you don't worry about it. It just kind of happens. All right? That's a huge benefit because doing async I/O correctly is not always the easiest thing to do. Doing it correctly, optimally, and across multiple platforms, that's a big task, right? So libuv kind of takes care of that, and that's a fantastic thing. What is it actually built for? Short-lived transactions, ones that are not CPU bound. High concurrent connections. There's this problem known as the 10K problem, which is, can I have my server host 10,000 concurrent connections at the same time? That doesn't mean 10,000 responses at the same instance. You can't do that. But 10,000 concurrent connections, right? Can I do that at all, right? Some environments you cannot. If you're spinning up 10,000 threads, for example, it's going to be quite challenging. Your server will be brought to its knees and not really do much work, actually. So it's good for high concurrent connections, but short-lived transactions, okay? Leverages JavaScript for high-level modules. Most of the stuff that you do npm install is straight JavaScript code. We have code that's actually C++ and JavaScript, but most of the stuff you see is just straight JavaScript code. That works great because JavaScript code is pretty easy to write. A lot of different kinds of people can write it. There's not a lot of compilation that goes on, so that's a good thing. You can gain access to standard C libraries through an interop thing. I'm going to show some of that. And it supports numerous platforms. Okay? Benefits of JavaScript. I already said it's easy to write. One of the benefits that some people gain is that you can run some of the code in the browser and some of the code on the server, and it's the same code because it's JavaScript. The V8 engine is pretty much the same thing that they use in at least the Chrome browser. So JavaScript is JavaScript on both ends. If you can run it there, you can probably run it here, depending on what modules you're using, right? This makes for very interesting applications and makes people who are doing stuff that spreads across the two pretty happy because it's only one language to learn, JavaScript, right? So, any questions? Pause for effect. All right.
What about TypeScript?
Go ahead. Yeah, no problem. Bravo. So yeah, you can use TypeScript, CoffeeScript, whatever you want, right? Because these are all just preprocessors. So as long as they spew JavaScript in the back end, it's going to work, right? And that's a great thing. There's another thing called asm.js, which is nothing more than a very restricted set of JavaScript. People are now writing compilers that spew asm.js out the back end. LLVM is a front end that will, for example, will spew asm.js out the back end. What does that mean? Any language that front ends using LLVM, which is the stuff that Apple supports. So I can write a C compiler, an Objective-C compiler, a Perl compiler, whatever I want, and it'll spew .js files, which I can essentially use in Node. Well, that's fantastic, isn't it? Because I can essentially choose whatever language I want as a front end, because it's going to spew JavaScript, which is going to work in Node. How cool is that? All right. So even if you're not writing JavaScript directly, since the world supports JavaScript in all sorts of different ways, you still get a leverage Node, even if you're not specifically sitting there as a script kiddie writing JavaScript code yourself, right? I think that's a pretty good thing. Okay. Multi-platform I mentioned briefly. Multi-platform for us, and I'll get to our application in a couple of slides. We needed to be able to have a runtime that would work as seamlessly in the cloud as on a desktop and your home router, okay? There are very few pieces of technology other than just writing straight C code that allow you to spread across all of those things. So the code that I run on the desktop machine, for example, we call it the connector in our case. That piece of code, I can run it on my desktop, Windows-based desktop, my Raspberry Pi, my ASUS router. It'll work on all of those environments without any code changes whatsoever, because it's all just straight JavaScript, Node sort of stuff. That's a pretty important aspect for us because it means that as a dev team, I can get platform reach without having to hire more devs that are very platform specific. I don't have to hire an ASUS router dev. I just have to, the same guy who wrote the code that runs on the PC is the same guy that's going to run it on that ASUS router. It's as simple as that, right? And for us, that's a benefit, okay? Consoles, game consoles, all that sort of stuff, it's all fair game. Node is kind of piggy, though, because it's a few megabytes, so you're probably not going to find it running in a light switch anytime soon, because it is a few megabytes. But, you know, these things change, okay? Some limitations. Node is all singing and dancing. Yeah, well, single-threaded has its benefits, but single-threaded also is a killer because as soon as you do compute-bound stuff, you're dead, okay? Since it is single-threaded and you're not preemptively booted from a long-running transaction, you will block your whole service if you do anything that's blocking, including CPU-bound stuff, right? If you use any I/O libraries that are not asynchronous and you have a blocking call, calling SQL Server in a synchronous way, you're dead, right? Your performance is just going to go down the tube. So it's a limitation you have to be aware of. They have a concept of being able to deal with child processes. So you can, in fact, create multiple threads, and there's lots of different ways of running multiple node instances within an environment behind IIS or anything else. But that's more and more and more. By default, the default environment where most people work, where they're not doing child processes and all that, if you become CPU bound, you will kill your server, right? It won't fall over and die, but you're going to kill your performance, okay? Does that answer the question, or did you want to spin on it more? Doing crypto. If you do a lot of crypto, like let's say we wanted to use Node straight up as the front end for ACS, for example, something we should know about. ACS does a lot of crypto work, so you're not going to get very high throughput through a system like that. It would be better if you use Node to front end the requests, hand off the CPU-bound stuff to another process, and then feed the results back, right? Yeah, and I'll get into that in the very end of the slides. But basically, you're going to run multiple instances of Node, and you're going to front-end it by something else that's going to handle the load balancing across those multiple instances. So you could, if you have a quad-core machine, run four node.xes, front-end that with IIS if you want, let IIS load balance across those four, and you'll get maximum CPU utilization, right? So, all right. No buffering. You have to actually respond fairly. Now this is changing somewhat, but you need to. You're responsible for grabbing stuff out of your network buffers as quickly as possible. There's not a long queue. This is not 0MQ, right? This is not IIS. There's not a heck of a lot of support here for buffering up the requests that are piling up behind your accept calls. So you have to be quickly pulling stuff off and putting it in buffers yourself, if that's what you're going to do. You also have to be very careful about garbage collection, which is Node is a garbage collected environment. JavaScript is a garbage collected language. So like C#, it's really easy to create strings and all sorts of stuff, but you're creating GC pressure when you do it. So you have to be extremely cautious. Now, this is the same thing I would say to anyone using C#, so there's no difference, but you have to be extremely aware because it's so easy to create objects using these environments that this will kill your performance because the GC is going to kick in, it's going to take however many milliseconds it takes, and there goes 3 or 4 transactions per second, right? So just things to be aware of. It's async aware but not enforced means that all the core calls are in fact async, like I said. The socket calls, the file system calls, the built-in calls are all async. But there's nothing that prevents you from standing up a library that makes a synchronous call on your own, right? So if you do that, you're going to kill performance. So it does not enforce, it has no way of enforcing this async model. It makes it really easy to use it, but there's nothing the environment does to prevent you from doing synchronous stuff. Just like it can't prevent you from doing CPU-bound stuff, right? All right. Questions? Okie doke. So use case. I talked about our application. It's called the Application Gateway. And the scenario is basically you've got your iPad or your phone or your whatever device you have, and you're sitting in a cafe somewhere, and you want to get at MSW or Toolbox or MS Library or even stuff that's at your home, okay? And when I mean sitting anywhere, I mean anywhere in the world, right? And your resources are located anywhere in the world, possibly here in Redmond, but possibly somewhere else. So we want to support hundreds of thousands or millions of users doing this in a very scalable way. We don't want to have, we don't want to support thousands of servers to do this, right? We want to have very low resource requirements. And that's about it, okay? So in order to do this, and just to see what our app looks like schematically, it's roughly this. We have this thing called a router, and this is where we use Node in 2 places, here and here. So there's this thing called a router, and this lives in Azure, and it's exactly what you would think it is. It's a router. You connect to it. It tells you where to go to get your stuff. We authenticate with Azure AD in the first place so that we know who you are and what you have access to. We have this thing called a connector that sits on your box somewhere in your network, and that's how we essentially do a reverse proxy to get to your stuff, okay? The hot spots in this diagram is certainly here at the router. Every single packet of data that flows through the system goes through that router, okay? Per user, data goes through a connector. So there's many thousands of these deployed. There's one of those. Now, that one looks like this. There are, in fact, right now, 3 router instances, one in Europe, one in the US, and one in Asia. Those 3 routers talk to each other. They share information about what's connected to them at different places in the world, which users are located where, which browsers are connected where. So they're constantly sending data to each other, forwarding packets. They're acting exactly like you would expect a hardware router to act, okay? But it's all in software, all right? This is all kind of front-ended by Akamai. Akamai is well, we use it for traffic management. So Akamai, you come in to your URL and it says, oh, I know of these 3 instances. He doesn't look busy. I'm going to hand him the packets. So Akamai allows us to land people on a router that's closest to them geographically. So if you're sitting in Singapore and you try to get to your stuff in Redmond, there's going to be a connection that goes like this, right? At least for the initial connection. And if you're sitting in Redmond and you're getting stuff in Redmond, you're going to hit this, and that's it. All right. So this architecture both is the router, it's a mesh, it's a proxy, it's lots of different things. Okay. In order to construct this, there's a couple of things we have to do, or 3 things we have to do. The core foundation of the router piece itself stands up port 80 and looks like an HTTP endpoint. You go and talk to it, you do REST calls and various HTTP stuff, URLs, okay? So it's an HTTP endpoint, HTTPS. Most web servers do that. No big deal, all right? But there's a secondary component, which is that mesh, the fact that I had 3 of them connected, and I can have any number of them connected around the world. Hopefully we'll scale up to tens, not thousands. That's a UDP connection. I know of all my nodes in my mesh, and I can talk to them, and I do talk to them on a regular basis, send heartbeats, and that's done through UDP. I also have a TCP connection to all of my peers in the mesh, because when I need to send the routing table, because a new guy shows up, I actually use TCP. And that is not HTTPS based, it's just a TCP socket. I send a well-known packet, they get it, they do what they're supposed to do, and life goes on, okay? So here I have 3 things that I'm doing with my web-based application, not just the regular HTTPS flow, right? On top of that, part of what I do is I get tokens from Azure Active Directory, compact tokens. I actually crack them, and I look for information inside. I'm looking for the username. You can argue that you shouldn't do that. You should use ACS or EvoSTS. Yes. But we do, in fact, do this. We've been doing it for the last year. So I have to write some low-level C interop code as well. These are different modules that I use that are out there in the world and what we use them for within the context of the service. Nothing super exciting here, you know. This is probably the most interesting one. This deals with going off and getting resources so I can easily make HTTP requests out from my router, okay? So this is what goes into our particular usage of Node. If I wanted to construct this using IIS, for example, I could probably do it. Most typically what you want to do for the front end part of it is you'd say, well, just tie into http.sys. You'll get a queue of stuff for all the HTTP requests. Great. Now, http.sys isn't going to help me much with the UDP flow for the mesh or the TCP flow for the mesh. So I'm writing that on my own, right? I'm rolling my own code. And it has nothing to do with my http.sys code at all. And somehow I've got to make these two work together, right? When you use Node, Node gives you multiple levels of access. I can access the sockets, I can access the higher level protocols, and the async flows are all the same. I don't have to do any magic for any of that. So being able to deal with these 3 different kinds of protocols, all using the same framework, is really beneficial to me, right? Because I don't have to learn a whole bunch of different technologies to do this. To throw on top of those 3 protocols, we're now supporting WebSockets. Soon enough, we might support Speedy, which is just another socket thing, and any number of protocols that may come along down the line. Node makes it pretty easy because someone has prototyped that protocol, probably in Node already, so you just go pick it up and use it, right? And it'll fit into the same exact framework. You don't have to create the protocol on your own and then try to shoehorn it into some other environment like http.sys, which would be kind of challenging. So that's pretty much what we use within the router itself. I'm going to show you a bit of code, just for shits and grins. If it comes back. I done broke it. No. Okay. Are you guys still awake? So I'll try to put you to sleep then. All right, so let's take a look at a simple bit of code. So I talked about the mesh nature of our service, meaning I have multiple instances of our router located around the world, and They all kind of talk to each other, okay? The way that works is, and I know this isn't going to make too much sense because it's just like, oh, eye chart of code on the screen. What am I looking at? This is a mesh instance. Here's my name. Here's a function that gets called whenever I receive a message, okay? This is all JavaScript code, right? Here's how I start the mesh, right? I create a UDP socket. Whenever there's a message, hand it to me because I have an on-message thing. Here I create the TCP socket, if you will, right? I'm both a server and a client for TCP because I can send and receive. I'm a peer, right? And I have this function that I'm going to call on a timer. One of the aspects of our service is we send heartbeats to see if our peers are alive. If they miss a couple of heartbeats, which is like 50 some odd seconds, we'll kick them out and say, they must not be around. The mesh will reconfigure itself and say, he's no longer with us, route around him, okay? This function does that. It's on a timer. If it receives a message before the timer times out, then it says, oh, okay. I was going to kill you off, but you seem to be here, so I'm not going to kill you off. All right, I can cancel the timer. But here you see the UDP socket I created. There's a configuration that tells me which port I want to use. There's other things I could configure, but that's all I do here. There's a function that gets called for the hello. There's the timer. Okay. Now in Node, I said I/O event driven. A timer is considered an I/O event. Forget the I/O part. The timer is an event. A socket being ready to be read from is an event. A file being ready to be read from is an event. So in Unix, where everything's a file handle, including the random number generator, events are everything. I/O events are everything. In Windows, it's slightly different, but the libuv library makes everything look the same anyway, right? This is a great thing. So I've got timers here. There's no, even though at the very lowest level of Node, you have to say, okay, well, how do I create a timer in Windows? At this level, I don't care, right? That's already been dealt with somewhere down in libuv. So all I have to do is say, create timer, right? And I hand it a function, and it just kind of deals with it, even though Windows timers are completely different than Unix timers are, and they're handled completely differently. But there you go. That's it. That's all there is to setting up my mesh. Create my UDP socket, my TCP server, and my timer function. The rest of this, the rest of the code in this particular file has to do with, well, what happens when the on-timer message fires, what happens when I get a UDP message, and these are the two different message types, hello and data, that sort of stuff, okay? At that point, I'm just writing JavaScript code, and I'm doing my thing, all right? Any questions? Yeah. Microphone.
So you're actually opening the UDP and TCP
Yes.
connections. What is the reason why you chose the UDP to be opened?
Well,
instead of keep using the
Open
TCP?
for UDP is kind of not real, because you're not really, UDP is not a connected protocol, right? It's just kind of sitting there. All you're doing is setting up the socket that's going to talk UDP. So every once in a while, I'm going to talk UDP. I don't want to have to construct the socket object every time I want to send a message. So I create the socket object, and then periodically I'm going to use that same socket object to send messages, right?
You
So
can do the similar one with the TCP as well, right?
What's that?
You can use the TCP sockets and keep reusing the same socket.
No, you don't really want to do that. Now TCP is different, right? TCP is an actual connection. You have two ends, and that's an established connection. So you're not going to use that same socket for UDP traffic. It's like, no, that's done, right? Two ports are locked, and that's it. So you have to separately say, oh, I'm going to talk UDP, so I'm going to create a separate socket for that, right? Does that make sense? I mean, you can't really use the same socket for two different protocols. Because when you set the socket up in the first place, you say which protocol you're using. Okay. Any more questions? Yeah.
How well does Node handle non-blocking operations on local files, which that tends to be an operation that's not universally supported that great for asynchronous I/O across operating systems?
It does as good a job as you could do, right, with that OS. So with Windows, for example, we completely support asynchronous calls on file operations. Depending on the Unix that you're using, it may be good or bad, depending, right? So they do their best, and they use whatever standard conventions are in Linux most frequently. It generally works, right? Now, files, of course, in Linux and Unix means completely different things than it does in Windows, because everything's a file handle. But for actual data files, you can probably get asynchronous communications. And if anything, if it can't do async at all, it's going to block, right? Or it'll do chunking, where it'll say, well, I'm going to read 10K at a time, and then I'm going to time slice, so I'm going to give up for a little bit and then come back. So I'll simulate it.
Would it ever like have a background thread that did the blocking read and then?
No, not unless you explicitly do it. Now, an implementation, of course, is free to do that. Like someone could take the libuv and say, on this particular, on AIX version 6.3, here's how we're going to handle, non-blocking file I/O. And you see this a lot of times, actually, when you go to Windows, where you say, well, how am I going to handle async sockets? I'm not going to use select. I don't have epoll. I should be using I/O completion ports. So there's a whole bunch of plumbing in there that's very I/O completion port specific for Windows, right? So what you would find is that per platform, someone is going to write code that makes it work as best as it can for that platform. It has to shoehorn its way into a fixed API, because libuv has a fixed API that everything above that is expecting. So they do their best to make it fit, and you get what you get, right? Any more questions? All right, so this was one piece of code. We have this other piece of code which goes and cracks RPS tokens. And there's a couple of things we had to do for that. First of all, we had to expose a couple of low-level calls from OpenSSL that were not exposed, because there were a couple of crypto functions that we needed that weren't there. So we had to expose those. And then we have to go and actually write the RPS cracking code. We chose to write that code in JavaScript because I had originally written that code in Lua, and it's a pretty straightforward port from Lua to JavaScript, so we just kind of ported that straight across. So this part right here, and I'm not going to bore you with the actual details because it doesn't matter, but just know that this is C code, or C++ code, whatever you want to think about it, okay? So you've got templates, and you've got your standard function parameters and all that. Kind of looks like JavaScript, but it's not. This is actually C code. Here's doing an RSA cipher object and blah, 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 okay? This is all the code related to doing some crypto stuff that I needed to expose, right? This little tiny piece of code, actually, I have to compile. When I compile Node from scratch, I have to compile this module as well because I'm going to include it in my node.exe, my version of node.exe. So it's just a piece of code that has to be there, okay? Separately, I have this JavaScript code which makes reference to that piece of code that I built, which includes the shim to allow me to access it from the JavaScript side, okay? And then I go off, and the rest of this file is actually the RSA, or the RPS cracking, token cracking. So knowing how to read data blobs and decrypt a ticket and blah, 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 okay? So this code is all JavaScript. And there's nothing spectacular about it. You're not going to get any major speed ups by writing this code in C because it's JITted code anyway, so it's already fast. All right? The interop is where things are slow, if anything. So that's why you write a nice, fast interop layer. But besides that, it's just code, right? Write it in whatever language you want. Okay? So that's that's typically how you embed some piece of functionality. So if you had some device that you're trying to get access to, like you had a hardware key store or something like that, that has a standard C library, you would write some amount of glue code to access that C library, and then you'd write, or a shim, and then you'd write some amount of JavaScript code that makes it look and feel like JavaScript in the way that you want to use it, right? And that's how you integrate stuff. This could have been done as a completely separate module, if you will, or you can just compile it into the application proper. And that's just a matter of how you want to distribute your code in the first place. Okay? Any questions?
What kind of makefile system do you have to learn to do to make some native code in there?
There's a couple of things you can play with. JIP, have you heard of that one? JIP is one of the ones that you can use. You can pretty much do whatever you want, but if you just went to their website, the Node website right now, and you downloaded the thing, the easiest thing for you to do is to install Python and then use the make system that they have based on that, right? Which is JIP. Besides that, if you didn't like all that, you could do it all in Visual C or CMake or whatever you want, really. So anything that can compile. But out of the box, Python with JIP.
So can I build a DLL in Visual Studio and Node can load that and call it?
Yeah, you can.
I conform to an interface?
Yeah. Because you're just going to export some functions, and then there's a way of saying, here's what that function looks like, here's how you stuff the parameters into the V8 VM. So at that point, you're just talking about how do I interact with V8, which is the JavaScript VM. How do I get a function call to show up, in that side? How do I do the marshalling? That's all it is, right? And that pretty much has nothing to do with Node. That's just V8, right? Which is not my best loved thing, but there you go. All right. I will finish out my slideware. Router instance. Okay, I think I talked about all of these things already. So what are the great benefits? Quick prototyping, module support. I get to focus on the application logic and not so much on the low-level stuff that has been done a billion times. Flexible network fabric and topologies, like I showed you, UDP, TCP, HTTPS, WebSockets. It's all pretty easy to get all of that stuff in there without having to change your application to accommodate every single time, right? Things to look out for. I talked about some of these. Garbage collection system. Great, I can be a brain-dead programmer and everything just works. I never have to deal with memory again. But you all know the pitfalls of doing that with C#. Same here. It's just JavaScript instead of C#. So don't do stuff that's going to be really painful for the garbage collection system. And leverage, when you leverage modules, there are literally thousands of modules out there in the world. They're not all good. And they don't all adhere to the Node way. For example, the low-level HTTP parser was written in C, does 0 allocations, really blazing fast, it's a perfect thing. But then there's all these things that are based on top of it, and you don't know what they're doing. If they just start throwing strings left and right, you kind of blew all the benefits of getting the low-level stuff written with 0 allocations. So you want to look at the libraries. Usually you only use stuff from people that are very experienced at it, and their modules are proven to be really good, that sort of thing. But this is a different kind of way of thinking and working for Microsoft, because typically we've been very much like, well, I got to build it myself. And in this world, it's like, well, why would I? Why would I waste my time building a module that already exists, right? So for the Node world, it's use something that's already been done rather than building it yourself, because then you keep going on your application and not wasting your time on that sort of stuff. All right. Alternatives. I'm almost done. The alternatives are numerous, right? Node plus other stuff. You can front end, I think I said this in the very beginning, you can front end Node with IIS if you wanted to, because since Node is, compute bound, you can have multiple instances of Node. They could be front-ended by an IIS server that round robins across them based on their load. You can do the same thing with Nginx. If you're using Linux, you're probably going to use Nginx, which is the new, you could call it the new Apache. It has nothing to do with Apache, but it's like the new kid on the block that is taking the performance crown, okay? So you could front-end your node processing with Nginx. Both cases here, they deal with the lowest level HTTP stuff. So they get the sockets in, they parse the headers, they hand you the request. Node then processes from then on. In that case, you're not using Node's HTTP parser, you're using Nginx HTTP parser, or with IIS, you're using the http.sys parser, right? So that's the way to go. If you don't want to be using Node at all, but you're using scripting or other things, Django, IIS, Apache, whatever, right? Any questions? Yes? For us to use, go ahead, repeat.
How easy was it to get the clearance from LCA or some legal department in Microsoft to use Node.js and some other libraries? Because you encourage to use existing library, which is a good thing, but often quite challenging to get allowed and cleared and approved.
Okay, I'll say some fluffy stuff, and then I'm going to point at Blaine, who actually did the work. So the fluffy stuff is, we as a company are kind of changing. I alluded to this a little bit. We used to get value, and our IP was based on us creating all these things. As a services company, that's not as important. What's important is getting the service out there, right? So our IP around creating this environment isn't as important as getting the service up and running. So Blaine, who is the dev who did all that work, what does it take? There.
It's fairly easy. We have folks in LCA that are already familiar with this community, with many of the modules. It's just a matter of obtaining the forms from them, filling them out, giving them the links and the licenses, and a few days later it's done.
Yeah, now
it's really easy.
We kind of, on some of this stuff, we were the first. So we got the battle scars for it, but the process is much better now. And you have Azure, for example, in general, has a Node SDK, and they're totally into Node stuff. They distribute Node modules all the time, and we use Node modules. So I think this is getting easier and easier. I think you'll find more resistance from your engineering group than you will find from LCA, right? Because we're manly men. We don't like to do things like use scripting languages and stuff like that. So that's a bigger hurdle to face. So, questions? I think that's it. The rest of this stuff, so here's a bunch of links. I believe the slides get handed out, so you can click on these things if you want. But there's nodejs.org is the primary org that has all the Node stuff. You can get the latest releases there. They're actually not the best place to get all the really useful information. All of those other links there are things related to Microsoft and Node, which is kind of interesting. We have our own Node.js Developer Center, if that helps answer the question of how Node-centric are we these days, and then various other things. So you can take a look at those links all you want. That's it. I hope you understand the magic of Node, and go for it.